Okay, so today we're not really going to do notes on this lesson because I feel like that the lesson doesn't need to be covered. We can basically figure out how to work through it by doing yesterday's opener and today's opener. So today what we're going to do, again, like what we did in yesterday's opener, is find the greatest common factor of the terms in each expression. Eventually, actually not eventually, on Tuesday when you guys come back from Martin Luther King, we are going to use that greatest common factor then to help us factor an area model, okay? So we're going to get into actually factoring next week, okay? So the first thing I'm going to do is just find the greatest common factor of these terms, though. In order to find the greatest common factor of each term, Logan, what do I do?
You have to
You have it on your paper. I can see it.
Yeah.
What did you do? You found two factors of 6, which means what are two numbers you can multiply together to get 6?
3 and 2.
Yeah, so we have 2 and 3. And what did you do with those two numbers?
I circled them.
You circled them because they're prime numbers. Means they only have two factors. One of the factors being the number 1 and the other factor being that actual number itself. Okay, and what about for 15?
I got 3 and 5.
Okay.
And I circled them to the primary.
Okay, and then you came out, I'm hoping, to the right or below or somewhere. Oh, and you wrote out your list, right? So for 6, you had 2 times 3. And for 15, you had 3 times 5. So what number do they have in common? What number do they share?
The 3.
Yeah, so they share a 3. So the greatest common factor is what, Logan? 3. Now, they have variables. So do they both have an x? Yeah, what's the one with the smallest exponent? X squared or just x by itself?
X.
Yeah. So the greatest common factor of these two terms is 3x. So the greatest common factor, once we find it, do you guys know what that represents on your area model? Do you remember from yesterday I showed you where we're going with this?
It represents your length.
Not your length.
Height.
There you go, your height. Okay, let's take a look at our next one here. So on your quiz on Friday, I kind of feel like we should make the quiz tomorrow and move on. But we have star. I think you guys are ready.
I feel like we should just wait until we're done with stuff.
Okay, yeah, okay. So we're going to factor these 3 terms. That's what you're going to see on your quiz on Friday. So what are 2 factors of 60, Maddie? Madeline?
Just
Maddie, I know. I don't know where that came from. What happened with that? I don't know either. Okay.
2 and 30.
2 and 30. Did anybody else use something different?
I use 6 and 10.
Yeah, and that's okay. As long as we end up with the same prime numbers at the end, okay, from 30.
2 and 15.
Okay, keep going.
And 3 and 5.
Okay, what about for 48?
2 and 24.
And for right now, we can ignore that negative. Okay, keep going.
2 and 12. 2 and 6. And 2 and 3.
And the last one. Ooh, that's a big one.
2 and 60.
Okay, 2 and 60. You could also use 10 and 12.
Yeah.
There's all kinds of different factors for 120. Okay.
2 and 30. I used 2 a lot.
Well, it doesn't matter because you're going to get down to 2s anyway.
2 and 15.
Yeah, you did use 2s a lot. You just got right in there. Okay.
And 3 and 5.
Nice job. What do I do with this information, Jenna?
You write it down on the side and then you see what all the numbers that they all have in common.
Okay, so what are my prime numbers for 60?
2 times 5 times, no wait, then 2, 3 and 5.
Another 2. Okay, I see what you're saying. Okay, and then for 48?
2 times 2 times 2 times 2 times 3.
So I had 4 of them. Okay, and then for 120?
And 2 times 2 times 2 times 3 times 5.
Okay, now we circle what they have in common. So what do they have in common? Okay, so they have a 2. They have another 2?
Yep.
and a 3. Anything else? No? Okay, so then the greatest common factor. Now, you guys do not have to write out 2 times 2 times 3 anymore. If you want to go ahead and just write what it multiplies together to be, you can do that. So you can skip this step of writing 2 times 3 equals right here, and you can just put that it equals what? 12. Okay, and then my variables, A to the what?
Third.
B and C. No, I disagree with that.
Oh,
2. Any questions on that one?
No.
No? How we do on it? Okay, make sure we have all of our words down
I did the last one.
and flip it over. All right. Just a second. Okay, this last one is what we did yesterday, using the area models backwards. So we're going to factor using the area model, so we're working it backwards. What information is provided for you here? So what does this represent? The area. And how do you know that?
because it doesn't have any difference.
That's right. And then we have our 3x, which represents the height. So what should I do with that area?
So, solve for length.
Well, where do I put it? Yeah, I'm going to solve for length. You're exactly right.
You put in the box and just put equals 6x to the squared
Okay.
and 15x. Next
Okay.
box.
So I know my height. I know my total area. So now I'm trying to find my length. So I'm going to take, what's the height of my first rectangle?
3x.
And is that the height of my second rectangle too?
No. Oh yeah.
Yeah.
I was thinking what 3 times 3 would be, and I was about to say.
So 3x times what gets me to 6x squared?
2x to the second power.
Now, if I put 2x to the second power, I want you to look at it. 2 times 3 is 6. X times x squared. How many x's will I have then? 3. Just 1x. Good. All right, Ben, next one. If I take 3x, what do I have to multiply it by to get to 15? 5. So I'm going to make sure I'm then going to come up and label the length of my area model, okay? And then from here I write out my answer. So this is area, so area equals height times length. So what's my height? So how do I write this out as my final answer?
3x for parentheses 2x plus 5.
Good, because I want to show that this is a representation of my height and my length. Any questions?